In this video we will introduce an extended type of polarization of light called cyclo-cycloid polarization. We know that light is a transversal wave because of the phenomenon of polarization. Polarization is a property unique to transverse waves. It involves restricting the vibrations of the wave to a particular direction. Light can be polarized, which means that its electric field vibrations can be filtered to oscillate in only one plane. If light were a longitudinal wave, like sound, it would not show polarization because longitudinal waves vibrate in the direction of propagation, and there's no perpendicular direction to filter. The vector in the top diagram describes the oscillation of the electric field of a linearly polarized light. The first two diagrams on the bottom trace the electric field vector over a complete cycle for linear polarization at two different orientations. These are each considered a distinct state of polarization. The linear polarization at 45 degrees can also be viewed as the addition of a horizontally linearly polarized wave and a vertically polarized wave of the same amplitude in the same phase. Now if one were to introduce a phase shift in between those horizontal and vertical polarization components, one would generally obtain elliptical polarization as is shown in the third figure. When the phase shift is exactly positive or negative 90 degrees, and the amplitudes are the same, then circular polarization is produced, as shown in fourth and fifth figures. Circular polarization can be created by sending linearly polarized light through a quarter wave plate oriented at 45 degrees to the linear polarization to create two components of the same amplitude with the required phase shift. The superposition of the original and phase-shifted components causes a rotating electric field vector, which is depicted in the animation on the right. Note that circular or elliptical polarization can involve either a clockwise or counterclockwise rotation of the field, depending on the relative phases of the components. So far, the oscillation in y-axis has the same frequency as the oscillation in x-axis. We can think of even more general cases where they are different, such as Lissajous curves. The difference in frequency between x and y-axis produce different pattern of field vector trace, as shown in the diagrams on the right. The combination of two frequencies can also be constructed as cyclo-cycloid, where both x and y-axes contains both frequencies, in contrast to Lissajous curves. A cyclo-cycloid is a roulette traced by a point attached to a circle of radius r rolling around, a fixed circle of radius r, where the point is at a distance d from the center of the exterior circle. If the traced point is restricted to the circumference of the rolling circle, we get hypocycloid. Hypocycloid is a special plane curve generated by the trace of a fixed point on a small circle that rolls within a larger circle. As the radius of the larger circle is increased, the hypocycloid becomes more like the cycloid created by rolling a circle on a line. The curve can be expressed by parametric equations as shown here. If k is a rational number, say k equals p over q expressed in simplest terms, then the curve has p cusps. Here are some examples of hypocycloid. The top row shows hypercycloid with integer k, while the bottom row shows hypocycloid with rational non-integer k. As seen in the parametric equation, producing a hypercycloid requires a mixing of two distinct frequencies. In this case, they are theta and k minus 1 times theta. The light with hypocycloid polarization state can be produced by combining two circularly polarized light beams with different frequencies using a beam splitter. In this example, k equals 3, resulting in a deltoid. Now the intensities of both sources are equal. The result is a rose with 3 petals. The circularly polarized light can be produced from linearly polarized light sources equipped with quarter wave plates, as shown in the diagram. In the next video, we will describe how to detect light with cyclo-cycloid polarization. Stay tuned.